Assalamualaikum and hi everyone. So today our group will present the assignment application of differentiation. So our group choose apply maximum and minimum problem. In this video we include the introduction, problem statement, problem solution, conclusion and references. What is differentiation? Differentiation can be defined as a derivative of a function with respect to an independent variable. Differentiation in calculus can be applied to measure the function per unit change in the independent variable. When do we apply differentiation? Differentiation is applied when we want to find rate of change, slope of line, maximum or minimum point, or analyze the behavior of function. It helps us optimize quantities, solve problem involving rate and understand how function change at specific point. There are 4 type application of differentiation. Number 1, related rate. Number 2, graph of rational function. Number 3, graph of polynomial function. And the last one is applied maximum and minimum problem.
Okay, what is applied maximum and minimum problems? Applied maximum and minimum problems involve finding the highest or lowest value of a quantity in a real world scenarios. These problems typically require the application of optimization techniques, specifically the use of differentiation to determine the optimal solution. This can involve maximizing profit, minimizing costs, optimizing resources allocation, maximizing efficiency, or minimizing risk, among other objectives. Okay, so for the next part is steps for solving maximum and minimum problem. For the first part, draw an appropriate figure and label the quantities relevant to the problem. Then, find a formula for the quantity to be maximized or minimized. After that, identify the quantity to be maximized or minimized as a function of one variable. After that, find the value of x when dy over dx is equal to 0 or f prime x is equal to 0. Then, find the second derivative or f double prime x and substitute x from 4 to difference between maximized and minimized value. If f double prime x greater than 0, it is minimum, and if double prime x is less than 0 is maximum. And lastly, to determine the value of y, whether maximized or minimized, substitute x into y.
Here are problem statement. A field is to be partitioned into 4 areas and each partition is enclosed by a fence, as shown in figure below. The total length of the fence is 200 meters. So here are the question in the 2D. Question A. Show that the total area of the field is A equals to 100x minus 5 over 2x squared. So first, 5x plus 2y equals to 200, and then 2y equals to 200 minus 5x, and then y equal to 200 minus 5x over 2, and the last one, y equals to 100 minus 5 over 2x. So the area equals to xy, and then we substitute y equals to 100 minus 5 over 2x in the equation, and we get 100x minus 5 over 2x squared, and it's shown that the area equals to 100x minus 5 over 2x squared.
So for the B part, determine the dimension of the field that will maximize the total area. So we got A equals to 100x minus 5 over 2x squared. Firstly we find the first derivative, which is the x, we minus 1 the power. So we get 100 x to the power of 1 minus 1 minus 2 times 5 over 2 x to the power of 2 minus 1. After that we get 100 minus 5x, and we calculate, we got x is equals to 20. So we substitute the value 20 into x. So we get y equals to 100 minus 5 over 2 times 20, and we times the 5 over 2 times 20, we got 50. Then 100 minus 50, we got 50. So y is 50.
For the question, find the maximum total area. Using this formula, d square multiply a per d multiply x square equal to negative 5 less than 0. It becomes its problem. Area equal to 100 multiply x minus 5 per 2 multiply x square. When x equal to 20, 100 multiply 20 minus 5 per 2 multiply 20 square. The answer is 1000. For the conclusion, after study this topic, we must know and able to understand the idea of differentiation and find a suitable formula or method that fit the question given. The field of user of calculus are very wide. It's enter into many fields and are not limited to specific pupil or to those who use it only, but to almost human being. Integration is not only a mathematical term, but is giving a way to solve a problem in real life. So here this reference for my assignment.